Last episode, we talked about why asynchronous code can be so dang hard to debug. So this time around, turns out asynchronous code also has their own call stacks that can be really useful when it comes to debugging them. So find out more on this episode of Visual Studio Toolbox. Hello, everyone, and welcome to another episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and last time we talked a little bit about asynchronous code and why it's so hard to debug sometimes. And we're continuing that thread a little bit by talking about how to actually go about debugging it. So joining me to do that today, once again, is Isadora Rodopoulos, who's a software engineer on the debugging team on Visual Studio. Welcome back.
Hello, Leslie. Nice to be back.
Sweet. So last time we talked about async code, why it's really annoying when it comes to debugging it. So
yes,
where did we start?
We stumbled upon a bug and then we basically didn't fix it, but we did manage to make it async. So that was something.
Baby steps.
Yes, you gotta go slow.
Yeah, so what do we do now that we have a better understanding about what the compiler was doing behind the scenes and what makes it so complicated despite it being a simple word like async versus await and that sort of thing?
So the main idea is that in part one, we just went through basically the sync scenario and then the async, and how similar they seem with just the async and await keyword, but they are actually very different under the hoods. And that's just a motivation on why you're not always seeing what you're expecting, especially when debugging. So basically for this next part, I just want to explain how can we acquire this data, because it can just look like magic, or we just think, oh, these are, of course, all running into threads, but they don't actually exist. They are all objects and state machines. So basically, we want to get through how do we get this data and what you should expect, what exactly you're looking at when you're debugging with Visual Studio.
Awesome. So let's just jump in. I'm all ears.
All right. So how do we debug this? So as first, I just want to bring as a concept the concept of async logical call stacks. And call stacks in debugging, for me personally, it's the first thing that I use while debugging, which is call stacks. And they are very important because they basically tell us the caller and callee relationship, which is basically how do we end up where we are. So whenever I'm breaking into a process or something like that, I want to know how exactly I ended up there in the first place. So following our previous example, we have this do lyrics request, which is being called from fetch lyrics, and then the playlist, which is trying to find the song, and then from our entry point. So I'm able to tell exactly how I ended up in do lyrics request in first place. And basically, whenever I get out of the lyrics request, I'm going to go back at fetch lyrics. So you can kind of interpret, this is for the synchronous scenario, that as soon as the lyrics request finishes, I'm going to get back and continue at fetch lyrics. But these are just regular call stacks that you see in sync scenarios. But what we want to pay attention now when async debugging is for the async call stacks, which are kind of different because they are not always in the same in the stack and just being unwinding to that.
Right. It's not always linear.
It can be everything. So just so we can kind of grasp exactly what is the difference between them, I have here just a table comparing sync and the async call stack and what would they actually mean under the hoods. So for example, on the sync scenario, the code is actually currently running in a thread. As in the async call stacks, code may not be running anywhere. They are just scheduled to run in the future. So for example, in our app, the app was frozen in the first place in the sync scenario because the UI thread was busy making all the calculations for the songs. And it was basically stuck on a request or anything. We didn't debug it through, so we don't exactly know, but we know it was busy somewhere. And this is exactly because the main thread is blocked. As in the async, we are still have an app responding because the main thread is free. We don't have any thread necessarily being blocked by any operation because everything was just scheduled to run sometime in the future. And again, oh yeah.
Oh no, I was just saying I can see why that might be tricky to parse. I mean, something is scheduled to run, you don't necessarily know when it's going to run, but
yes, they are just scattered around, and we don't exactly. And without any debugging tools, we barely have where to start. And another thing is that sync call stacks, they have an actual physical stack. That is, they have actual resources. They allocated some space in the stack to be run. As in the async, again, we have this concept of virtual or logical stacks. That is, it's not tied to any thread necessarily, or just a single. Sometimes we can just have some operation in async running, and it may never even reach the thread because it's all OS. It's all just reading files, for example. So we don't know. And we usually work with this concept of virtual thread, which is basically just trying to mock what a thread would be if we had one in async. And again, as I mentioned, we have, for example, local variables, and they are all on the stack. So they are all accessible, and then you can open and see the local variables. Whereas in the async, we don't have the local variables. We do have that state machine class that we have seen previously, and they do get, so we have all the information there, so it's there. But it's not as straightforward as sync because it's all within fields, and it's not an actual resource in a thread. So given all that, how exactly could we possibly build an async call stack? And to run that, I just want to go through and let's see this example that we have seen before again. So we are trying to find a song, and then we fetch the lyrics asynchronously. And then as soon as that finishes, we are going to resume whatever we were doing in that method. So in the async word, each bit of async code has a reference to the next bit that will follow. And that's what we have seen with these boxes. So we usually call that a continuation. And it's not, it actually has a reason because it has a field. So in the task object, so each async method generates a state machine class. And that is a task object per se. And then each of the task object, it has a field for continuation. And that is basically a pointer telling us wherever we are going next as soon as that operation is finished. So for example, we are fetching the lyrics, and when that finishes, we want to continue with something else. So when we are doing everything without any async or await, we were doing a continue with. So that kind of follows a similar pattern. As soon as we finish fetching the lyrics async, we want to continue somewhere. And that is the box below, which is in the try find song async, and it's basically just comparing the lyrics. So here, as I mentioned, the await keyword adds the line of try find song async as a continuation to fetch lyrics async, so we know where to resume as soon as we get the lyrics. And the task of fetch lyrics async stores a reference to the next line of try found async. So basically, they are just connecting to each other as soon as they finishes. And then with that, actually, so we basically just get all of these continuation fields, and then we are able to get a chain of continuations. And with that, for example, so we had this before, which was fetch lyrics async and then try find song async. So we basically run through all of them, and we group together into what we call an async logical stack. So here you have something much more similar to the sync scenario, where we got all of these task objects, weirdness, state machines that the user don't really care about because everything was syntax sugar in the first place. And we syntax sugar for them as well in the debugger, and we just have this async logical stack, which is very similar to what we had before, which is basically we have the fetch lyrics async, and as soon as that finishes, we are going back to the try and find song async. But the difference that this is all async, so it's not in a thread. It's all just manipulation on all of these feeds in the state machine. And this chain of continuations is what we call the async call stack in the first place. So it's nothing more than just manipulating all these task objects into something that is going to execute right after each other. So this is all just to provide a rich debugging experience. So we can actually click on each of these frames, in the fetch lyrics async and try find song async, and then we can see the source line info, and we can see local variables. And this is just like the sync experience.
Yeah, that is so much more helpful to have like a tangible representation of what this whole workflow looks like. I mean, async logical call stack, that wasn't in Visual Studio for a while, right? That's like a new addition.
Yes, it has been recently added and being worked through a lot with .NET team, and that's why we are so proud and just announcing and just like trying, because for so long async has been seen as something really hard to start with, because it is hard. It is hard to implement. It's hard to debug, but it's worth it. And if we can just make a richer debugging experience, a lot of more people could be doing async work, which is always cool.
There's a lot of magic involved at first.
Yes, there's a lot of magic, but the thing that I like about magics is knowing how they happen, so I can actually understand what's going on.
Exactly. I enjoy finding out how the magician does the trick. So
and so you can also know what you're looking at.
Yeah, and saves a lot of frustration in the long run once you better understand what it looks like.
Yes, especially when things don't go as expected.
Oh yeah. Which, that happens a lot. So,
exactly.
I can't.
So basically, just like speaking of things not going as expected, we also have some notes on async and sync stacks, and some of tricks of what you can expect in each of those. So we know that async stacks are continuation stacks. That basically each pinch of async code is tied to the next bit that will follow. And we have the same example as before. But one thing that we have to be careful is that, and this is tricky, is that basically this is the context. This may be different than the creation stack. The creation stack would mean where something was created in the first place, as in continuation stack is purely what's going to continue. So just this might be tricky to get at first. So I have an example to help us out and just try to understand why it can be particularly tricky. So let's say I have the same example on playlist, and then for each of the songs, I'm getting the lyrics, but I'm trying not to throttle and make the server angry with me. So each time that I get a song, I'm just taking a break and waiting for like 10 seconds. So I have this take a break method, and I'm just waiting for that task. And then if you look at the async stack, you see, okay, let's see what's going on, because I'm obviously delaying somewhere. And you can see that we have a task delay, and then we are back to fetch all lyrics async. And if you are not very familiar with async, or like even I forget about it a lot of times, I just think, okay, but where's take a break? Because that's who created the thing, and I'm expecting to see that. If this was a sync code, obviously I would see there. And so you're just, so you're just, why is this not showing up there? And so one thing that we have to take note of is that take a break is not part of the async call stack, because if you know there, it does not have the async keyword. So it does not have any state machine tied to it. All that happens is just a regular sync method that happens to return a task. And that task is the task.delay, which is a method with an actual async keyword. And that then is awaiting for fetch all lyrics async. So basically, this is something we have to be really mindful when passing awaitables around, is that the async call stacks won't necessarily reflect where they were created, but rather how and where they are being awaited and waited. And,
Gosh. Yep, that's definitely a lot to take in. There's a stack for everything, but yeah, it makes sense.
And this one gets tricky because sometimes you have a lot of methods calling each other, and you're not really sure if they are async or not, because it's just a tiny keyword.
Right.
It's supposed to be
a little keyword with a lot of power.
Yes, it basically does the whole thing. So yes, the whole state machine. And here we are just passing around something else. So we don't even have this information to put in this async stack.
Yeah.
And it's not even an async method. So it doesn't even make sense to be there as well.
Nope. Because if you put a wait in front of take a break, then, I mean, both stacks will look totally different.
Yeah, if you put an await in take a break and then we await inside of the return, the test of delay, then we would see the take a break inside there because it would have a state machine and then we would be awaited on that, which happens to be awaiting for test delay.
Yep. Good stuff.
Yes, tricky.
But it's nice to know the difference because, you know, if you expect something to be in a stack and it turns out it's not there and you're confused as to why, that's not really helpful either. So
yes, that's why it's important to know the tools and how do they work so I can actually not be so lost.
Yep.
Because otherwise I'm very lost as well.
Exactly.
So here I just have something just following up with creation and continuation stack, which we just discussed. So why is this so not so intuitive for us? It's because in the sync call stacks, they are the same because it makes sense. Like they are all being logically executed. So the return, basically the control returns immediately to the caller. So that always exists. The continuation stacks and the creation stacks are the same. And the other thing is that in async, the control goes to whoever waits for the current async code, which may be different from the method which was originally called, which we have just seen before. So this is something we have to be careful on things that don't rely on async methods. For example, if you're more familiar with async code, you might have used test completion source before, and it's basically something that just awaits for random tasks. So you won't see who created them mostly. You just see the async tasks itself. So you miss the creation stack in that scenario, for example. And just something that you can keep in mind is like you can think like the famous jazz singer and just say, it isn't where you came from, it's where you're going that counts. And that's basically what we think with tasks. It's who's being waited on and where it's going.
Yeah, that makes total sense. Yep, that is great stuff.
Yeah. Yeah, no, it's very tricky. But we just learn with practice and just debugging. And then it's very rewarding when we are just debugging something. You're like, all right, I already know what's happening here. It's that.
Mm-hmm. Instead of just trying to scratch your head at how do I even start debugging versus like how I can actually debug my problem.
So. Definitely. So I already added something that is tricky. We have something else that it can be tricky, but all of this is just so we can keep in mind. It's basically, so our async stacks really just stacks, like a single stack. And here I have an example, which is we are fetching all the lyrics, and then we have a task when all. So what we are doing here, we are getting all these songs, and when all of the songs complete, we will just await for all of these operations. So in the sync scenario, we would have to make them in order and just execute them. But in async, we have something like that. So this is how the async call stack would look like. It's basically a bunch of operations, and then they are all going to continue at the same place. So suddenly you have this graph. So they don't have to be flat or linear. So we don't have a one-to-one relationship anymore. And similarly, you might also have a single task, which has multiple continuations because a lot of different async methods are waiting on that same task. So so suddenly we don't have more one-to-one, and we just have to deal with all of these different relationships, which is the graph.
Yeah, and not to fully spoil part 3 of our mini series on this, but that looks an awful lot like the parallel stacks tool window.
Yes, precisely. And I even have a screenshot here, is that async stacks are actually graphs as we have seen, and they can get really weird, like even weirder than we have seen before. So for example, here I have a chicken and egg problem.
Ooh, yeah.
What came first? And then we have chicken and egg, and they're just waiting on each other. And then suddenly we have cyclical tests as well. So it's a graph with a cycle on it. So it's not even as linear is not sufficiently enough. We also have like some really tricky and different graphs to look at.
Yep, that is definitely a challenge. So I do like having the visual there as a visual learner.
Yeah.
Better have that.
As you notice here, we do have this pattern for the Paulus tests window, and it's a graph. And now maybe it makes more sense, like, to anyone who's using that it's a graph, because it needs to be a graph. It can have multiple continuations. So that's the main structure of it.
Yeah, good stuff.
And yeah, that's basically the wrap up for this second part.
Awesome. Well, I'm very hyped to actually see this in action in Visual Studio, which we're definitely going to be talking about in the next part. So join us next time when we talk about how to actually debug your async code in Visual Studio. And we're going to show off all the cool tools like Parallel Stacks tool and other ones that I'm sure you're excited to share as well.
All right. So
Sweet.
See you then.
Yes. See y'all then. So until next time, happy coding, y'all.